Hello, welcome back. We're going to begin solving higher order polynomials and finding factors and finding solutions. So we're going to start by looking at some special patterns to look for in higher order polynomials. Today we're going to look at the sum of cubes and the difference of cubes. The first thing we want to do is be able to recognize them, and then we want to be able to factor them, and then we want to be able to solve them. So the sum of cubes has exactly two terms. They're both perfect cubes, and there's a plus sign in between them, okay? So examples would be x cubed, x is being cubed, and 8, 2 is being cubed. Another example would be 8x cubed. That would be 2x that's being cubed, and then a 1, which is 1 being cubed, all right? The difference of cubes, again, has exactly two terms. They're both perfect cubes, but notice that there is a minus sign between them. So we could have x cubed minus 8 and 8x cubed minus 1. So it's helpful if we know some of our perfect cubes. So why don't you answer the video question and then come back and we'll fill this in. All right, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. When we factor the sum or difference of cubes, we follow a pattern. Now, you're going to learn later on in higher order math classes about the binomial theorem and how to expand these. But for right now, it's important that you just learn them and be able to use them, all right? So if we have a sum of cubes, which is the first is a perfect cube, the second is a perfect cube, and there's a plus sign, we're going to our binomial will be the first plus the second, just one of them, not the cube, just one factor, okay? And then you're going to square that first term. You're going to multiply the two terms together, and you're going to square the last term, okay? So notice the sign pattern has letters over it. It's an acronym, okay? So S stands for the same sign as the original, as your original difference of or sum of cubes, okay? O stands for the opposite sign of the original. So this is plus, so my O is minus. And then AP is always positive. Okay? So let's do one together. All right, here is x cubed plus 8. So x is being cubed and 2 is being cubed. So my first is an x, my second is a 2. Notice that I'm going to do my signs last, okay? Put that in parentheses, and then I'm going to square my first, x squared. I'm going to multiply 2 and x together, that's 2x, and then I'm going to square 2, just following the pattern. Now I'm going to put in my signs, same, opposite, always positive. And I'm done. I factored it. The difference of cubes works the same way. You have a perfect cube and a minus sign between them. Then you're going to go the first minus the second, first squared plus first times the second, plus second squared. It follows the same mnemonic, same, opposite, always positive for the signs, okay? So let's do it with 8x cubed minus 27. And here's what we get. 2x is being cubed and 3 is being cubed. So I'm going to go 2x and a 3. Then I'm going to do 2x squared. So that gives me 4x squared. Now I'm going to multiply 3 times 2x. That's going to give me 6x. And I'm going to square 3. That gives me 9. And now I'm going to place my signs. Same as the original, minus, opposite, plus, always positive, plus. And you've done it. So here's your video questions. Come back and see if you get them right. All right. The first one is a difference of cubes. X is being cubed and 4 is being cubed, and there's a minus sign in between them. So I'm going to go x and 4, and then I'm going to go the first squared, x squared. Then I'm going to multiply 4 and x together and get 4x. Then I'm going to square 4, and that gives me 16. Now I'm going to place my signs. Same, opposite, always positive. Just like that. Same, opposite, always positive. All right, for the second one, I have 3x that's being cubed, and I have 4 that's being cubed, and it's the sum. So I'm going to do 3x and a 4. Then I'm going to square 3x, and that's going to give me 9x squared. I'm going to multiply 3 and 4 together. That gives me 12x. And then I'm going to square 4. That gives me 16. Now I'm going to place my signs. Same, opposite, always positive. Same, opposite, always positive. Just like that. Good job. Now we're going to learn to factor it. We're going to learn to solve it by factoring. So what we're going to do is we're going to factor first, and then we're going to set each factor equal to 0 and solve. Okay? So this is x that's being cubed, and this is 3 that's being cubed, and there's a minus sign in between them. Okay? So I'm going to go x and 3, and then I'm going to go x squared. That's squaring of the first. Then I'm going to multiply 3 and x together, and that gives me 3x. And then I'm going to square 3. That gives me 9. And then I'm going to place my signs. Same, opposite, always positive. That's what we learned before. Now we're going to use the zero product property that we learned back in chapter 5. Okay? If these two things are equal to 0, that means that x minus 3 can equal 0, or, I'm going to give myself a lot of room, or x squared plus 3x plus 9 can equal 0. Okay? On this one, this is just solving a simple linear binomial. X equals 3. This gives me this ordered pair 3, 0. This is a real solution. Okay? A real solution. Got all kinds of randomness going on here. Okay. For the trinomial, you have to use the quadratic formula. It's not factorable, okay? It's not factorable, so we're going to use the quadratic formula. So the first thing we're going to do is we're going to calculate b squared minus 4ac, and that's going to give me 9 minus 4 times 1 times 9, and this equals negative 27, all right? So now I have x equals negative b plus or minus square root b squared minus 4ac all over 2a. And now I'm going to plug it in, and I've already figured this out. So I have x equals negative 3 plus or minus the square root of negative 27 over 2a. Well, let's factor this. We know we're going to have to take an I out because of that negative, and this is 3 root 3. So I have x equals negative 3 plus or minus 3i. That takes care of my negative under the radical. And then 3 over, that should just be 2. Okay, 2 times 1 is 2. And these are your 2 complex. And you can leave them just in that form, just like that. 2 complex. Okay? All right, your turn. You try this one. Come back. If you missed it, come back and see where you went awry. All right, I have x that's being cubed, and I have 5 that's being cubed. So I'm going to get x and a 5. Then I'm going to get x squared and a 5x and a 25. Then I'm going to place my signs, same as original, opposite of original, always positive. Okay, that's what we did before. Now we're going to solve. So that means x plus 5 could equal 0. All I did was just move it down here. So x equals -5, and this is the point -5, 0. And this is your real solution. And then I'm going to use a quadratic formula for x squared minus 5x plus 25 equals 0. I'm going to start by finding b squared minus 4ac, and that's going to give me 25 minus 4 times 1 times 25. So I get that equals -75. So I get x equals negative b, so that's 5 plus or minus root -75 over 2 times 1, that's 2. Now I'm going to simplify this. I know the I comes out, and this is 3 and 25. And 25 is 5 and 5. So I get x equals 5 plus or minus 5i, because I'm taking that pair out, root 3 over 2. And you can leave it just like that. These are your 2 complex. 2 complex and 1 real. We're going to learn in future that the degree of the polynomial tells you the total number of solutions you have. It could be real, they could be complex. All right, go ahead and try number 5. Come back and check to see how you did. All right, we have 4x that is being cubed, and we have 5 that is being cubed. Okay, and so we get 4x plus 5, and then we get 16x squared plus 20x plus 25. I'm going to set 4x minus 5 equal to 0. X equals, oops, that should be a plus, -5/4, and so I get the real solution, -5/4, 0, just like that. Now for the 16x squared plus 20x plus 25, I'm going to use the quadratic formula. And I'm going to start with b squared minus 4ac, and so that gives me 400 minus 4 times 16 times 25, and that actually gives me -1200. And I'm going to prime factor this one, and when I do, I'm going to take a few shortcuts here just for sake of time. This is 112, this is 10 and 10, and this is, can't hardly read that. 3 and 4 and 2 and 2. So I'm going to take out 20 and leave under the 3, and I'm going to take out the I as well. So I have x equals -20 plus or minus, oops, sorry about that, -20 plus or minus 20i root 3 all over 32. And then I'm going to divide top and bottom by, reduce it by 4. And this should be a negative. I just caught this, sorry. I'm going to erase here for just a second. I didn't check my signs. This one here, that should be a negative. Oh, my pen's doing something funny, wouldn't you know it? So this is a negative. And that makes that a positive. Okay, so now I'm going to reduce by 4 on top and bottom, and I get x equals 5 plus or minus 5i root 3 all over 8. There we go. And these are our two complex. Right? Here we go. I think this is our last one that we're coming up on. Okay, and now here's one thing that you want to look for. Let's say you have a candidate for, you have two terms, and your variable is cubed, but perhaps like your coefficient on your variable isn't cubed. Look to see if you can reduce that first. So notice that if I divide everything through by 2, I can get 27x cubed plus 64 equals 0. Okay, this is a perfect cube and this is a perfect cube. 27x cubed is a perfect cube, 64 is a perfect cube. I'm going to get the same results as this one. All right, you're going to factor, so we're going to have this is 3x and this is 4, so we're going to have 3x plus 4, and then we're going to have 9x squared and 12x and 16. Same, opposite, always positive. And then we're going to get 3x plus 4 equals 0. So x equals negative 4/3. So we'll have negative 4/3, and that's our real. And then we're going to take 9x squared minus 12x plus 16. And I'm going to figure out b squared minus 4ac. And that's going to give me 144 minus 4 times 9 times 16. And with that, I get negative 432, which is 3 and 144, and that's 12 and 12. So I'm going to get x equals the opposite of negative 12, so I'm going to get 12 plus or minus, and then negative 432 over 18, and then I'm going to get x equals 12 plus or minus 12i root 3 over 18, and I'm going to divide top and bottom by 6, so I get x equals 2 plus or minus 2i root 3 over 3. Whoops. Yep, over 3. Okay? I divided top and bottom by 6. All right, so here's what we're going to work on tomorrow. Oh. Why don't you try this one on your own and come back and take a peek. I'm going to divide it by 2. That's going to give me 8x cubed minus 125 equals 0. And then you would proceed from there. This would be 2x and this would be 5. And I think you have the process down. So this would be 2x minus 5 and then 4x squared, opposite sign, plus 10x, always positive, 25. And then we would proceed from there. Okay? So here's what we're going to work on in class. See you then. Thanks for listening.